Hello students, good morning. Today we are going to see a lesson unit number 4. The name is hydrogen. Okay, before going to this subject, what are the main objectives of this lesson? So in this chapter we are going to learn first you are going to see the position of the hydrogen in the periodic table. So we already know that hydrogen present in the periodic table in the first position. So here also what are the position of this hydrogen in the periodic table. Next one is what are the different isotopes of hydrogen. What are the different isotopes? Proton, protium, deuterium and tritium. So that is called as isotopes of hydrogen. So what are the method of preparation of hydrogen? What are the properties of hydrogen? What are the uses of hydrogen? So next we are going to see what are the different types of hydrides and what are the knowledge in the structure, explain the physical chemical properties. Next one is what is meant by hot water and what is the suitable method for water softening, and heavy water, how to explain the property. And next one is what are the hydrogen peroxide, what are the properties of hydrogen peroxide. Next one is what are the bond types of bond present in this hydrogen compound. So that is intermolecular hydrogen bonding and intramolecular hydrogen bonding. These are all we are going to learn in this chapter. First we are going to see what is the position of this hydrogen. So first we are going to see what is meant by hydrogen. Hydrogen is the simple atom, contains one electron and one proton. So everyone know that. So hydrogen is containing one electron and one proton. So what is the hydrogen atom? Atomic number, how to write? 1 hydrogen 1. Okay, that is atomic number is 1 and mass number is also 1. So in other element except helium, the valence electron is directly to the sphere of the nucleus. So that is the hydrogen atom. That is in our daily life we came across so many things. So that is water containing hydrogen and carbohydrate containing hydrogen. So these are the so many proteins also containing hydrogen. So in this we can unpaired electrons. So unpaired electrons, it is ready to exist in the diatomic molecule. So that is the hydrogen present in the form of hydrogen molecule. So what is the difference between atom and molecule? Atom means that is single one atom, that is atom. What is molecule? That is hydrogen molecule H2. That is the molecule. So here that is the earth atmosphere. So however abundance of the hydrogen in the earth atmosphere is very small. So in hydrogen in the atmospheric air very small present, very small quantity is present in the atmospheric hydrogen. Next we are going to see what are the position in the periodic table. Why the hydrogen present in the position in the first periodic table? So we already know that what is the periodic table position. The hydrogen has the electronic configuration 1s1. So the outermost shell only one electron. So that is here the only one electron mean it is resembles in general electronic configuration ns1. So that is the reason it is present in the first periodic table. So the periodic table first group column. So the first column similarly with this follows. So what is the character? What are the first one is it forms unipositive ion like alkali metals. So that is sodium, potassium, cesium, rubidium, cesium. These are all called the unipositive metals. Unipositive ion. What is meant by unipositive ion? The atom containing only one ion. Say for example, hydrogen containing only one atom, right? Atomic number hydrogen is only 1. How to write electronic configuration is 1s1, right? So that is the atomic number 1s1. How to? So this is the electronic configuration of hydrogen. So that is there is only one positive ion like alkali. All the alkali metals, sodium, potassium, rubidium, cesium, the first group elements all containing only the unipositive ion. And another one is it forms halides, oxides and sulfides and also alkali metals. So this is the hydrogen. So hydrogen when combined with halogen. What is meant by halogen? Chlorine, bromine, iodine, fluorine. So these are all halides, oxides. So that is hydrogen combined with oxygen. Peroxide, that is 2 molecule of oxygen. Sulfide, hydrogen react with sulfide to form hydrogen sulfide. What oxide mean? Water. So halide mean hydrogen halide. So halide example, what are the halide example? Chlorine, bromine and iodine, then fluorine. So what are the example of this one? So first one is okay, what are the example of this one? So first one is hydrogen halide HCl. Okay, this is the halide. Instead of X, it is contain halides. So another one is alkali metal. So that is NaS, Na2O, Na2O2. So these are all the alkali metal. Next one is it is also act as a reducing agent. So what is meant by reducing agent? So however, the alkali metal which have ionization energy. So the ionization energy also ranging from 377 to 520 kilojoule mole. The hydrogen has the 1.314 kilojoule mole, which is much higher than the alkali metal. So it is a good act as a good reducing agent. So why it is a reducing agent? Unlike alkali metal which have ionization energy ranging. So ionization energy top to bottom, ionization energy decreases. The size of the atom is very small. Means what is meant by ionization? Ionization energy, the energy required to remove the electron from the outermost shell, that is called as ionization energy. Here also, that is ionization energy will be decreases. So that is another one is that the formation of halides. So halogen, hydrogen also tendency to gain one electron and to form a hydrate ion. So that is the first one is when this hydrogen, so when this is the halides form halogen, hydrogen also has a tendency to gain one electron to form hydrate ion whose electronic configuration is similar to the noble gases. Say for example, hydrogen gain one electron. So electronic configuration of hydrogen is 1s1. So that is gain one electron means so the hydrogen gain one electron. So to form hydrogen molecule, right? So that is the gain H2 minus. So this is the H2. Okay, so this is the hydrogen molecule. So next one is this halogen, hence the tendency of the hydrogen to form the hydrate ion. So this is the another one. So next one is, okay, so the hydrogen is gain one electron to form the whose electronic configuration is similar to the noble gases helium. So that is hydrogen. Helium atomic number is 2, right? The helium atomic number 2, that is 1s2. So gain one electron, it is similar to the noble gas configuration, that is helium. So this the another one is this hence the tendency of hydrogen to form the hydrate ion. So that is the reason the hydrogen have the tendency to form the hydrate ion. What is meant by hydrate ion? H minus ion. So this is called as hydrate ion. Hydrate ion means that is H minus ion. Okay, so this is the another one. So next one is, so this is another one, is a low compared to that halogen to form the halide ion, evident for this. So this is the halide. So hydrogen gain one electron, that is hydrate ion. So this is the first one. So that is the thing explained, that is the last paragraph we see. So that is hydrogen molecule gain one electron, that is H minus ion, that is hydrate ion. So since the hydrogen has the similarities with the alkali metal as well as the halogen, so this hydrogen have the similar properties of this first group metal and also the similarities of this halogen also. What is the halogen group? That is 17th group element. So what are halogens? So bromine, fluorine, chlorine, bromine, iodine. So that is called as halogen. So it is difficult to find the right position in the periodic table. So among all these, in this paragraph we concluded that hydrogen எப்படி இருந்தது அப்படின்னா first group properties similar to alkali metal, first group மாதிரியும் இருந்தது, சில properties பார்க்கும்போது 17th group elements மாதிரி இருந்தது. ஸோ அதனால உங்களுக்கு எந்த பொசிஷனில் வந்து போடணும், ஃபர்ஸ்ட் பொசிஷனில் போடணுமா 17th பொசிஷன். ஸோ தே ஆர் காம்பவுண்ட், தே ஆர் டிஸ்கஸிங் அபவுட் தட். ஸோ அக்கார்டிங் டு த காம்பவுண்ட் ஆஃப் ஹைட்ரஜன் எக்ஸிட், தட் இஸ் according to the oxidation state. Oxidation state means we already studied what is oxidation state. So the charge of this atom, so that is the oxidation state is +1. So therefore it is to place the hydrogen in group of 1 along with alkali metal instead of 17th group in the according to the IUPAC periodic table. Okay, so that is the reason hydrogen. So this is one book back question, why hydrogen, explain the position of this hydrogen in the periodic table. So we already know that in the normal latest periodic table hydrogen is present in the first group elements, but here, so why it is present in the first group elements? So that is the main thing. So it is because it is the similar properties of this alkali metal and also it is similar properties of this halogen. So that is the two, both the character is that according to this oxidation state it will present in the first group. So that is the another one. So next one is, what are the isotopes of hydrogen? What is the isotopes of hydrogen? Hydrogen has the 3 naturally occurring isotopes. So first one is protium, deuterium and the tritium. So what is protium? Protium is 1H1. What is deuterium? 1H2 instead of D. Tritium 1H3. Okay, that is the 3 thing. Is the predominant form of and is the only isotope does not contain a neutron. So that is the, and another one is this protium is the predominant form and is the only isotope that does not contain neutron. So that is the protium. This is only also does not contain the neutron. So remaining thing, deuterium contain only 1 proton and only 1 neutron. So this is tritium contain 1 proton and 2 neutron. That is protium contain only 1 proton only, no neutron. So sometimes they are asking for one more. So that is the no neutron present in that isotopes of hydrogen, that is protium. Okay, so next one is deuterium is also have a heavy hydrogen or constitute about 0.015. So the other name of deuterium is heavy hydrogen. Okay, normal hydrogen and the other one is radioactive hydrogen. So the third isotope tritium is the radioactive isotope. So the tritium is the radioactive isotope only in the traces. So that is the only small quantity only present in this atmosphere. Due to these isotopes naturally occurring hydrogen exist. Hydrogen, HD, deuterium, HT and tritium. So these the properties of this isotopes. So next one is this hydrogen containing protium, deuterium and the tritium. So the protium is the normal hydrogen, deuterium is the heavy hydrogen. So protium is the normal hydrogen. Okay, so that you understand that protium, normally hydrogen cell, that is called as protium. So and the deuterium and tritium. Deuterium is the heavy hydrogen and tritium is the radioactive isotope. So these are all the another one. So next we are going to see the properties of the hydrogen, deuterium, tritium and the molecules. So first one is what are the symbol of hydrogen, protium, deuterium, tritium. So I already told protium is the normal hydrogen. So that is the normal hydrogen. Next one is atomic mass. So how much? 1.08 deuterium, tritium. Number of electrons, that is 1 proton, 1 neutron, 1 proton and 1 electron. So no neutron, that is hydrogen protium. That is 1 proton, 1 neutron, 1 electron. And another one is 1 proton, 1 neutron and the 1 proton, 1 electron and 2 neutron. Okay, so that is called as radioactive isotopes. So it is a stability radioactive. So these are all the tabular column of this hydrogen. So next we are going to see the what is mean by ortho and para hydrogen. So important 2 mark question, what is mean by ortho and para hydrogen. So in the hydrogen atom, nucleus has a spin. When a molecular hybrid spin, 2 hydrogen nuclei can be in the same direction, that is on the proton and neutron. So suppose we are draw this diagram, that is only, that is proton and neutron, that is here one hydrogen, this is another hydrogen. So both the atoms are rotating in the same direction. So that is called as ortho. So in the opposite direction, that is called as para. Okay, what is meant by ortho and para? When a molecular hybrid, the spin of 2 hydrogen nuclei, that this is the 2 hydrogen, this is one hydrogen atom, this is another hydrogen atom, the same rotating can be same direction or in the same, that is called as what is that? That is ortho hydrogen. So next one is the hydrogen are in the opposite direction, that is the opposite direction, that is called as para hydrogen. So next one is, so what is the thing next we are going to see them at room temperature. Normal hydrogen consists of about 75% of ortho form and 25% of para form. So normally, so suppose hydrogen present in the particular place means what will happen? The nitrogen 75% is present in the ortho form and 25% in the para form. But the ortho form is more stable and the para form, the conversion of one isomer. So that is the temperature when the equilibrium shift to the favor of para hydrogen when the temperature is lowered. So suppose when the temperature is reduced, the ortho hydrogen is converted into para hydrogen. The para form can be catalytically transformed into ortho form by platinum and that is the para hydrogen. This para hydrogen is converted to, so this para hydrogen is converted to ortho hydrogen. So that is the lower the temperature. Temperature will be decreased temperature. So what will happen? The temperature will be decreases. So that is the reason. This is the another one. So all the para-hydrogen is transferred into ortho-hydrogen. The para form can be catalytically transferred to ortho form using the platinum, in the presence of platinum and ions. Okay, so that is the another one. Alternatively, it can also be converted by passing in electric discharge heating under the 800 degrees Celsius and mixing with a paramagnetic molecule such as oxygen, NO, nitro, NO2. So what is the meaning for that? Then the ortho form of the alternatively, so how it will converted into, so that is the passing one tube passing the electric discharge tube, heating takes place at 800 degrees centigrade and mixing with the paramagnetic molecules. So paramagnetic molecules, so that is now oxygen, nitrogen, nitrogen dioxide, nitrogen trioxide. So with the nascent atomic oxygen, so react with nascent atomic oxygen to form the converted into one form to another form. Okay. So next one, ortho and para-hydrogen are similar in the chemical properties but differ in some of the physical properties. So example, melting point of para-hydrogen is 13.95 and the boiling point is 20. Why that? The ortho-hydrogen is, since the nuclear spins are opposite direction or magnetic moment, and para-hydrogen is 0 and ortho-hydrogen has the magnetic moment twice that of a proton. So what is meant by magnetic moment? According to the spin rotation of the nuclei of the electron and the proton, the para-hydrogen, the magnetic moment of the para-hydrogen become 0. So that is the para-hydrogen becomes 0 and the ortho-hydrogen as the magnetic moment is called the proton. So okay, so this is the another one. So next one is how to prepare the hydrogen. So normally we already know that how to prepare the hydrogen. So here that is the high purity hydrogen is obtained by the electrolysis of water containing traces of acid and alkali. So normally we are taking the water with react with acid or alkali. What is acid? Acid means HCl or alkali means sodium hydroxide solution in the presence of sodium hydroxide or potassium hydroxide using a nickel anode and iron cathode. So see this diagram. Okay, so this is the diagram. So here that is the one bottom of the round bottom flask. So here that is pure water is taken, sodium hydroxide is taken, and the what are the nickel anode and the iron cathode. We are taking the what is meant by electrolytes. Electrolytes means one cathode and anode will be present. So that is the reason. However, the process is economical large scale production. So that is at anode, so that is the OH minus hydroxyl ion, H2 of molecule 2 electron. The cathode gain that electron, overall reaction water molecule separately. So that is the first method of preparation of hydrogen. So normally how to prepare the hydrogen? Dissolve this normal water is dissolved with alkali or acid in the presence of sodium hydroxide to form this hydrogen. Okay, so this is the another one. Next we are going to see the what are the laboratory preparation of this hydrogen. Hydrogen is conveniently prepared in the laboratory by the reaction of metal such as zinc ion tin with dilute acid. Normally in the laboratory preparation, the large scale preparation, we are react with zinc and hydrochloric acid to form the zinc chloride and the hydrogen molecule. Okay, so this is the another one. So next one is what is the industrial production of this hydrogen, how it will production in the industry. So in the large scale, hydrogen is produced by steaming reforming the hydrocarbons. When methane burn with water in the presence of nickel catalyst, so that is the passed over the nickel catalyst at 800 to 900 degrees Celsius, 35 atmospheric pressure to form the hydrogen. So first method in the large scale hydrogen is prepared. So hydrogen is in the large scale, hydrogen is prepared by burning of this methane catalyst in the presence of nickel to form the carbon monoxide and hydrogen. In the another process, steam is passed over a red hot coke to produce carbon monoxide and hydrogen. So the mixture of the gases is known as water gas. What is meant by water gas? CO plus H2 is a water gas. This is also called syngas. So synthetic gas, is other name is syngas. And another one is it is used in the synthesis of organic compound such as methanol and simple hydrocarbon. Carbon plus water in the presence of 1000 degrees Celsius, carbon monoxide plus H3. So that is the water gas hydrogen. So water gas hydrogen, so that is called as carbon monoxide plus hydrogen. This is the water gas. The water gas. This is also called as synthetic gas. Okay, so how it will water gas is prepared. Carbon when react with water molecule in the presence of 1000 degree carbon monoxide plus H2. So that is called as water gas or the syn gas. Okay, so next one is what are the conversion of carbon monoxide into water gas by the carbon dioxide. Okay, so next one is conversion of carbon. So conversion of carbon monoxide, first one is converted into carbon dioxide by mixing the gas mixture and more steam at 400 degree passed over a shipped container containing iron copper catalyst. The reaction is always a water gas shift reaction. So here that is not only a single reaction, it is shifted the two reaction, converted carbon dioxide by mixing with the gas mixture with more steam at 400 degrees Celsius and passed over a shift converter. So another one is, so next we are going to see the conversion of carbon monoxide in water gas to carbon dioxide. So that is water gas. What is water gas? CO plus H2. So the CO and H2 is converted into CO2 and H2. So that is called as water gas shift reaction. So that is in the presence of iron and copper catalyst at 400 degrees Celsius. It will, so here that is 400 degree Celsius it heating and in the presence of iron and copper. So iron and copper and iron, it will converted into water shift. The carbon dioxide formed in the above process, it is absorbed by the potassium carbonate. The potassium carbonate and sodium chloride, these are absorb the carbon dioxide, that is potassium carbonate. So what is that reaction? Carbon dioxide absorb the potassium carbonate and water to form the potassium bicarbonate. What is this compound name? Potassium bicarbonate. Okay, so this is the another one reaction. So next we are going to see the what are the preparation of deuterium. So what are the preparation of deuterium is, first one is electrolysis of heavy water. So here that is what is meant by electrolysis of heavy water. What is heavy water? The deuterium is the heavy water. I already told deuterium is the heavy water. Deuterium oxide, the normal water contain 1.6% and power minus 4% of heavy water. So normally water contain 1.6% of heavy water. What is heavy water? Deuterium oxide. Deuterium oxide is the heavy water, right? So that is the when water is electrolyzed, the hydrogen is liberated much faster than the deuterium. So deuterium is liberated. How to prepare deuterium? Electrolysis of heavy water. Normally water is electrolyzed using the electrolytic reaction. So it is converted into deuterium. So this is the heavy water. Further electricity heavy water gives the deuterium. So that is deuterium oxide. Next one is another one important 2-mark question. So that is preparation of tritium. What is how to prepare tritium? Tritium is the radioactive isotopes of hydrogen. So the tritium is the bombarding of the. So what is how to prepare deuterium? So that is deuterium is the bombarding the lithium. So here that is lithium is bombarding the slow neutron. There is 0n1, what is known, that is called as neutron. Slow neutron, it is bombarded. Bombarded means they strike the lithium ion, lithium molecule, it is liberated helium. Helium, this is called as tritium 1T3. So what is the meaning for that? 1 electron. So that is the 3 proton, so 2 proton and 1 neutron. So that is called as tritium. Okay, the nuclear transmutation reaction for this process, that is called as nuclear fission reactor. So neutrons in a nuclear fission reactor, that is the radioactive equation. So radioactive equation, this is the way they are writing. So that is the 3 is the lithium 3. So that is the lithium 3 is the mass number, 6 is the atomic number. That is 0n1 is also, that is the neutron. So 0n1 neutron, this is the tritium. Okay, so this is the another one. Next one is what are the properties of this hydrogen. So what are the properties of hydrogen? Hydrogen is the colorless and odorless gas and tasteless, lightest and highly flammable gas. So hydrogen is a no color, no odor, so and the non-polar diatomic molecule. So non-polar diatomic molecule, that is the reason it can be easily liquefied under the low temperature. Hydrogen is a good reducing agent. So you already know that hydrogen is a good reducing agent. And another one is what are the chemical properties? Hydrogen react with oxygen to give the water. That is the explosive reaction. Hydrogen, when normally hydrogen react with water to form the explosive reaction. So that is hydrogen react with oxygen to form the water molecule. This is the first one reaction. Another one is hydrogen react with halogen. What is mean by halogen? Halogen, chlorine, bromine, fluorine and iodine. Okay, so this is the halogen. So these halogen corresponding halides. What is mean by halide? Hydrogen. X is represent halide. Halogen, fluorine, chlorine, bromine, iodine. So here that is the writing in explosive violence. While the chlorine is at room temperature under light, it combines with bromine on heating the reaction with iodine and photochemical reaction. So that is the way react with hydrogen molecule to form the hydrogen halide. Next one is the above reaction. The hydrogen as the oxidation state is +1. So again it is formed the hydride. The oxidation state of hydrogen is -1. In some cases the oxidation of hydrogen is -1. How it will explain? That is lithium hydride. How to calculate the oxidation number of hydrogen? That is lithium oxidation number is lithium +1, right? So we are writing the how to calculate the oxidation number. So we are going to calculate hydrogen. So that is X, lithium is +1 equal to 0, X is equal to -1. So the hydrogen oxidation state is -1. So that is the reason. So all the hydrate, it is also tendency to react with reactive metals. In this reaction with metal, it will form the hydrate. So corresponding hydrate, sodium hydride, lithium hydride. When this hydrogen react with metal, lithium, sodium, so these are all the metal means to form the hydrates. Okay, this is the another one is these hydrates are used as a reducing agent and also in the organic chemistry. So and also it is another important hydrate is lithium aluminum hydride. So another one is important hydrate is lithium aluminum hydride. So in organic chemistry, lithium aluminum hydrate, lithium aluminum hydrate, this is one act as a reducing agent. Okay, so this is the another one. So next one is, so here that is the lithium aluminum hydride. So here lithium aluminum hydrate, right? Lithium hydrate react with aluminum chloride, lithium aluminum hydrate in the lithium chloride, sodium hydrate, so then the triethoxy boride. So this is also called as a reducing agent. These all catalysts are used in this organic chemistry. Sodium borohydrate. So that is sodium borohydrate. So this is the another one. Hydrogen itself acts as a reducing agent in the presence of nickel catalyst. So that is, what is this compound name? So what is this compound name? So this is called as acetylene. So CH triple bond CH, this is acetylene when react with nickel catalyst to reduction with hydrogen to form the ethylene. Acetylene, ethylene and ethane. So what is the compound name? This is acetylene. Acetylene. This is called as ethylene. Ethylene. This is called as ethane. Okay, so this is the compound name. So what is the acetylene? Acetylene, that is triple bond, that is called as unsaturated organic compound, then saturated organic compound. What is the word meaning of saturated? What is the word meaning of unsaturated? So everyone until 10th standard, what is saturated? So the compound is saturated. So that is in inorganic chemistry, saturated means according to the that is the solvent nature of this compound. So here that is organic chemistry. What is word meaning of saturated? Saturated means the compound containing single bond. So what is mean by unsaturated? The compound containing double bond and triple bond, that is called as unsaturated. See this compound, the triple bond is there, so it is called as unsaturated. Here double bond is there, that the compound is called as unsaturated. Here the single bond is there, the compound is called as saturated. Okay, so this is the another one. So these are the properties of this. These are the chemical properties of this hydrogen. So next we are going to see what are the chemical properties of deuterium. What are the chemical properties of deuterium? So unless hydrogen, so this is the chemical properties of deuterium. Like hydrogen, deuterium is the oxygen. When deuterium react with oxygen to form the deuterium oxide, deuterium react with halogen to form deuterium halide. So all the reactions are similar to this protium. Okay, protium, that is deuterium. Like hydrogen, deuterium is also as the oxygen. So deuterium is the exchange reaction. What is meant by exchange reaction? So here that is CH4, that is methane. H4 molecule is there. Instead of H, the deuterium is exchanged. So that is called as deuterium. So here that is CH4. Here that is CD4. That is the CD4. So here NH3. Here also ND3. So this is the another one. So these are all the exchange reaction of this deuterium. Next one is what are the properties of tritium. So what are the properties? It is a beta emitter with a half-life period. Mainly already we know that what is the properties of tritium is a radioactive element. So that is, it is the half-life period is very important. Repeatedly asking 1 mark. So that is 12.3 years. So that is the properties of tritium. So next we are going to see what are the uses of hydrogen. What are the uses of hydrogen? So that is 90% of hydrogen produced in industry is used for the synthetic application. One such process is the Haber process. How it is mainly this hydrogen used in the preparation of large scale ammonia. So how it will prepared in the large scale of ammonia. So that is we are studied in this equation, right, in the first lesson. That is nitrogen, 3 molecule of hydrogen, that is 15 moles of ammonia. That is your equation. So that is this equation, nitrogen, ammonia. Hydrogen is react to form this ammonia. This is compound. This reaction is otherwise called as Haber's process. Okay, Haber's process and synthesis of ammonia. And another one is it can be used to manufacture a methyl alcohol, industrial solvent, that is methanol. Methanol otherwise called as methyl alcohol. Carbon react with hydrogen, copper catalyst to form the methyl alcohol. Another one is unsaturated fatty oils can be converted into saturated fat called the vanaspati. So again unsaturated fatty oils can be converted into saturated. Unsaturated na enna sonna? Unsaturated, the compound containing double bond. What is saturated? Compound containing single bond. That is unsaturated compound can be converted into saturated in the presence of catalyst, platinum and hydrogen. And another one is metallurgy. Hydrogen can be used in the reduce many metal oxide. So many compound metal oxide reduced with hydrogen to form the copper. So that is tungsten. What is W? Tungsten oxide to form the tungsten. W mean that is tungsten. Okay, another one is atomic hydrogen. Oxyhydrogen torches are used for cutting and welding. So for cutting and welding the metals, this atomic hydrogen or oxyhydrogen torches can be used. Okay, so another one is liquid hydrogen. Liquid hydrogen is used as a rocket fuel. So the liquid hydrogen is used as a rocket fuel. So another one is hydrogen is used in the fuel cell generating electrical energy, and also the uptake of the reversible uptake of hydrogen in metal also attractive for the rechargeable metal hydride battery. So mainly it is used in the rechargeable metal hydride battery. This hydrogen is also used. Okay, that's all about this hydrogen. So next we are going to see what are the compounds of hydrogen, and another one is what are the physical properties and chemical properties of this hydrogen. We see the next video. Okay, thank you children.